So this is Containing Chaos with Kubernetes. If this is not the session that you were supposed to be in, then you're in the wrong place. My name is Terry Ryan. I'm a developer advocate for Google. So that's pretty much all you need to know to get started. But let me ask you guys a couple questions about you guys. Help me know where to start, what jokes I can make, that sort of thing. So I assume everyone here is on the DevOps spectrum somewhere. Is there anyone who's not from that community here? Right? You're either a developer or an operator, right? All right, cool. Or both, right? Has anyone here not played with containers at all? Like you haven't touched it, you haven't looked at Docker? Okay, there's a couple. How many don't know what containers are at all? No? All right, good. All right, that gives me a place to start. And just for personal information, how many people here were at the Docker is horseshit session last night? Okay. How many people fall on that spectrum of belief that the whole container thing is overhyped? How many people are like loving containers? And how many people are reserving judgment because no one's really using them in production yet? Okay. All right, good. All right. All right, good. So that gives me a good idea of where we are and what we can talk about. So I'm going to skip ahead. I did have a whole section kind of starting with containers in case you weren't there. I'm disappointed I don't get to use this slide talking about VMs, that you could replace your laptop bag with an oil drum and it'll do what you want it to do, but it won't really get you there. A little metaphor there. Okay, so intro, Kubernetes. Why Kubernetes? What is the problem that we're trying to solve with Kubernetes? Because a lot of times we talk about this technology and we talk about it and like we kind of jump right into it. I want to say what it is. What is the actual problem that we're trying to deal with? So okay, so you've come over to containers. Let's say for sake of argument, you're suspending your disbelief and you've come over and started to use containers. So you have a front end and services container set up. That's both your web front end and your services combined, and then you have a back end that's running MySQL. To quote people from yesterday, the boring stack here, right? PHP, MySQL, but you know, kind of everyone will understand what we're doing here. And so we set up a easy, simple environment here. We've got a front end and a back end, and everyone's happy. And if something happens, we get a little bit more traffic, we can easily add more front ends, and it all sort of, okay, we're fine. Then comes along and says, hey, having front ends and services on the same container is causing us all sorts of problems. It'd be nice if we split these up. So you do that, right? You have just services on this one, and then you add a front end that's just HTML, JavaScript, CSS, right? So you now have 3-tier architecture instead of 2, and then you're looking like this. Okay, we're a little bit, you know, a little bit more what we're kind of used to. And then someone points out like, hey, you know, if this container dies, this MySQL container dies, like we lose everything. Okay, all right, so we need a volume. So we set up a volume, and now we're looking like this. And so, you know, we get a little bit more traffic, we add some front end, and we get a little bit more, and we can start splitting up MySQL and getting a little redundancy. Okay, so, all right, here we are. Now, all of this is running, like we kind of abstracted away all this stuff, but like under the covers, this is still running on a machine that has memory and processor and disk and other resources. And you know, at some point we do need to worry about them. Okay, so we're not that redundant, let's switch over. So now we have multiple machines. How do we route stuff? Like, can machines on this, can the containers in this machine talk to the containers on that machine? Should they? If we do, how do we set that up? We have to set up networking. And what happens if one of the machines dies? We have to move stuff over. Okay, that's a lot. We went from just like really simple and hey, this is fun and this is easy and something to play with to like a lot to manage. And that's where Kubernetes comes in. Instead of basically setting up all of that, you basically throw some processors at it, throw some resources, and you say, this is what I want, and Kubernetes lets you go with it. All right, so Kubernetes is a container orchestration system. It's open source, and it's started by Google, and has been contributed to by a series of others. And now I'm going to go through and start talking about what Kubernetes, how it's built up, and I need to address a couple concepts first. Has anybody here not heard the cattle not pets argument? Anyone like, you're like, I've never heard that before ever. Okay, so first thing, we kind of come at this from the, let me just speed through this, that we want our stuff to be pets and not cattle. right? The next major philosophy is desired state. Desired state is what we call a declarative way of setting up setup instead of an imperative. So you're used to in the imperative model of saying like, all right, we'll do this, build Docker images, all right, then launch the front end, and then launch services, and then launch a back end, all right, and then if something were to happen and one of these machines dies, something has to respond to that, or maybe someone, right? Like, but basically you have to respond to that and somehow kind of start up your script from somewhere else. Declarative goes a different way. It says desired state, there should be 3 front ends, 2 services, and 1 back end. And Kubernetes will just run it for you, right? That's all you say. This is what I want, and Kubernetes does it. So if something happens and a machine dies, without human intervention, Kubernetes will restart one of these machines for you as if nothing ever happened. You'll get logs and everything because obviously something happened, but you don't have to worry about it. So if I wanted to do a fun metaphor for it, like cattle, not pets, I would say it's like an employee versus a child. All right, so let's say you have a tough day with an employee or even a coworker, and you say to them, you had a tough day, go home, get some sleep. That's really all you need to tell your coworker or employee, right? On the other hand, if you have a child, you cannot tell them just go to sleep, right? You have to say, go upstairs, get undressed, put on pajamas, brush your teeth, pick out 2 stories. And for those that don't have kids, you might say, like, do you really have to tell them to go upstairs? Yes, you do have to tell them to go upstairs, or you'll have a naked child in your living room, right? So this is the difference here. We're talking about treating our services like employees instead of like children, right? Now, it has to be you can't just magically treat a child like an employee, so you need to have set up and all that. So, okay, so components. You could try. You can really try. It just does not work. Components. So there are a number of things that make up a Kubernetes setup, and the first thing, the atomic unit, is called a pod. Now, a pod can consist of 1 or more containers, and they're going to share IP addresses and namespace. So you basically combine multiple containers onto the same pod and have them treated as one logical machine. Now, it's okay just to have 1 container. I found this when we go to the documentation and start playing with Kubernetes. It immediately starts out with pod, and you can have more than 1 container, and it kind of starts like that's where you'd want to go. But for a lot of use cases, you don't need more than one container in a pod. You can run just 1 container in 1 pod. Examples of why you'd want to mix this stuff up. The canonical one we do is a web server versus file sync. So you've got 2 containers. One is serving up web content. The other one is a file sync that's getting the web content from someplace authoritative and populating it so the web server has something to do. They're 2 distinct jobs, 2 distinct things we want to be doing, so we put them on the same one. If you want to put all your services on 1 container or 1 kind of logical machine, but have it split up among multiple containers, that's another way you would do it. And if, let's say, not you, right? You didn't do this, but someone is still running like an all-in-one machine where you've got database and right. You've never, right? No, right? Some other jerk that you used to work with did that, and now you're responsible for it, okay? And if you want, like, all the code is probably written to talk like on localhost. So what you would do is you would bring all constituent parts over as containers as part of the first step of correcting that architecture, right? So there's a couple of reasons why you'd want to do more than 1 container in a pod. So this is what a pod configuration file looks like. I know, very exciting. It's YAML. Some highlights from this, kind pod, pretty on the nose there. Some metadata, set some names for it, and then I set an image. This image is going from a private repository. We could just as easily go to the Docker, the public Docker repository, and pull down images. So containers are therefore subatomic in Kubernetes. You cannot have a naked container, as much fun as it is to say naked container. Sounds like you're doing something wrong. You have to put a sock on the container. But they're Docker files just like you're used to, the same exact syntax, same everything. So next major concept is controllers. So these handle that whole declarative, the desired state idea. So basically, I love this example, replication controllers. We only actually, right now, only have replication controllers. Down the road, there's going to be other controllers, but for now, if you think controller, you're really thinking replication controller. And replication controller handles, all right, you said you wanted 5 of these things. So now I'm going to look and observe the current state. If the current state is not 5, if I do a diff and it's running 3 and 5 are supposed to be running, I'm going to act and start up another 2. Or if I'm supposed to have 3 and I have 5, it's going to see that there are 5 running and kill the other 2. Configuration file for this is a little bit more complex. And again, I'll highlight just the things that are important. Kind replication controller, give it a name, front-end controller. This is important. Basically, this template is the type of pod that you want to run in that replication controller, which is kind of interesting. And basically, you don't end up writing a lot of pod files. You end up writing mostly replication controller files that contain pod files in them. You can't link them for some reason. There's probably an explanation somewhere, but I don't have it. But right here on this app, I put to-do. It's a to-do app if it's not obvious that we're running here, dash front end. And that's going to be important later when we get to services. Again, I pull down an image and pretty much exactly like a pod otherwise. So then services defines a set of pods that work together for a common purpose. So all of my front end apps are going to run on a service. I'm going to give them a virtual IP address, and it's used for exposing the application either to other services within Kubernetes or externally. I can set up external addresses that way too. So if I look at the config file for this, again, just a lot of metadata, setting names and labels and whatnot. But then the important one here is app equals to-do.fe. Basically, any pod that is running with app name this will be served up by this service. So it's the way of linking those two concepts. So that leads us to labels. So I looked a little bit at labels. We looked at app, and that's what you use them for. The other part of that was selector, saying, use this label to be your service. And basically, it's metadata for your objects, and it's completely arbitrary. You can do whatever you want with them. In this case, I have 3 labels. I have an app, a tier, and an environment, so I can do things like select the entire front end and do something to the entire front end, or select the entire prod version and do something to that. And that's how labels and selectors work. Okay, last thing before I actually get showing off Kubernetes in action is networking. So pod IPs are all routable, which means that instead of the Docker way of doing it where you go through the Docker bridge to talk to the other hosts, machines will be able to talk directly to one another. You can set up security and you can handle rules like that, but most part, networking is really straightforward and easy. And then combine it with a DNS service underneath in Kubernetes, and you can route services pretty easily to the correct places it needs to go. So pods can reach each other without NAT, and they can talk amongst nodes of the Kubernetes cluster without you having to do any work. So basically, as long as they're in the same Kubernetes cluster, they'll be able to talk to each other. Whether or not you want that or not is a different matter, and you need to lock things down, but it makes reaching out to other containers or other pods really, really easy. So okay, so I'm going to show off Kubernetes in action. I'm going to set up some things before the demo. I had to do a whole bunch of stuff. So I'm like, this is the last time. This is the recap of that. Long story short, I set up some machines that are running Kubernetes on them. I then set up a virtual disk so I don't run into that whole, the MySQL container dies and my data goes, boom. I built some Docker images, and then I shipped those images to a private Docker repository. All of this took about 10 minutes. Which would be agonizing slow up on the stage in front of you. I'd have to stall a lot. I have a video, but again, it's just stuff like transferring. It's not that exciting. Most of that 10 minutes took place here, building the images and pushing them over a network, over my hotel Wi-Fi to the repository. So it sort of makes sense that would take the most amount of time. And that's basically everything I have going already. So The app is pretty simple. I did not pull it into 3 tiers because, as if you've talked to me, you'll discover that I'm pretty lazy. So I really only wanted 2. Someday we'll go 3, but and this is again lazy bootstrap, just on a to-do app, pretty simple. All right, so now let's run some Kubernetes. So I have Kubernetes running, and I'm going to do stuff from command line. And I'm really terrible at like mashing my hand against the keyboard and messing stuff up. So I have shell scripts, but the shell scripts will tell you exactly what it's doing as it goes through. So let's start some services. So the first thing I'm going to fire up is you see that it's grabbing, oh, I'm sorry, it's really dark. But basically this right here, kubectl create from a file, and that file is the PHP replication controller. So you'll see there that it fired up 2 pods based on that replication controller. And then I'm going to pull up the service, and the service did the same thing, or a similar thing. It built from a file, and it was that YAML file that I showed you earlier. And basically it is the front end for those 2 guys, and you see that it's doing exactly what we said. If the app name matches, then serve up from these 2 pods. Okay? Next thing I'm going to do is I'm going to launch my MySQL server. That's going to launch. Yellow means it's pending. The PHP servers go up really fast. The MySQL one takes a little bit longer. And then I'm going to create a service for MySQL. And there is the service for MySQL. Okay, so now this is my architecture. This is all set up. The only thing that's not happening that I need to happen, that takes a couple seconds, is for my service there to get a public IP. And as soon as it gets a public IP, I'll pull it.
The service is redundant. I mean, if you run everything on 2 nodes or 3 nodes or gazillion nodes, and you fire up a service to a certain amount of backend, what happens? Which instance? It's a special instance on the nodes that holds the service?
Great question. So how is this service made redundant? It's right now it's running on it's basically controlled by the master controller for Kubernetes, which is not high availability yet. So you do have a single point of failure. We are aware of that. We're working on it, but it is running from the master controller. Yes, a layer up. Yet. It's a 1.0, right? So okay, so this is my environment. Oh, actually the app is serving. I've got a public IP address, so I can go and check that out. And we see that this is running. And it's a real app, not dummied. Do it live. Save. All right, we added a record. Okay, so it's all living. All right, so what's the first thing I might want to do? Well, the first thing I might want to do is find out that, hey, you know, we're having a substantially increased load. I would like to increase the number of pods that are running my front end. Okay, this is actually pretty simple. I'm going to bump this up because I realize it's kind of hard to read. Bear with me. There we go. So I'm going to write kubectl scale replication controller. The replication controller I want to do that to is front end dash controller. And I want to make replicas, what do you think, 4? Yeah, I'll go 4. If I go like 10, it'll blow up. Not because Kubernetes can't handle it, because I'm in front of a crowd of people. And there we go. So I've added another 4 nodes. So I now have a 4 pod service serving up on this. Sorry, I'm pointing it here. Running on that service. That service's load balance is going to handle making sure that each one of these nodes is getting some of the traffic, which is kind of fun. And obviously, I can script this and do it either proactively. I can say like I always get more traffic this time of day, and so I'll add more pods, or I can do it reactively, like to an alert. Basically, this is pretty good to go. So the next thing that might come up is from time to time developers say like, oh, like this whole light background, this is terrible, right? We want to update we want it to be cool and hipster and dark, right? We want the dark version of this. So they, of course, update the code, and so I've already gone through and created a Docker image, like I would still have to do that. I have to create a Docker image with the new code, get it ready, publish it, and make a new version of it, put it up onto the repository. That's already done. So, because it's already done, I can just run a file to handle that. So what I'm going to do is say, I would like to update. I'd like to update these to the new version of the code. So what I do, and we'll see this conceptually when it happens, is I'll create a new front-end controller that's pointing at the old stuff, and basically have the new ones, basically spit up new ones and take down old ones as the new ones come up. So I'm going to run that, and you'll see basically I have a rolling update command, front-end controller, update period 2 seconds. I've added a new front-end controller. It's going to add an extra pod. It's going to wait till that pod is actually serving, theory, and then drop one of the other ones, one of the V1s. So we see one V2 has been added, there's 3 V1s. It'll roll through and do this, and the only thing I had to do to get that working is you'll see here I have 2 replication controller files, one PHP and one PHP dark. I'm gonna compare those files for you. And we'll see there's not that much difference. Oh, I'm sorry, that's really dark. Can you guys read it in the back, at least kind of get an idea? What's that? Okay, no, it's my bad, I apologize. So the differences are pretty slight, right? I have a different image. I also have a different version. That's really important, making sure those version numbers are different so it knows that it's something different so it can scale over to it, and having a different ID and name. Everything else is exactly the same. So now, when I go back here, we'll see that in a second it's going to take down, and there we are, we switched over to front-end controller dark. So now, when I look at it, my hipster developer designers are happy because it's now the dark version, which is, of course, completely unreadable, and I apologize for that, but it's still the same exact app. We see the do it live I just added. So everything's the same except for the CSS and some of the HTML. So that is a quick demo of it. I just want to make sure I got everything I want to talk about. Yep. All right, so you had a question? Mm-hmm. You want to run 2 versions at the same time? Completely stop one and then completely start another one? Sure.
You need a new service probably.
Yeah, you do. So I guess what I'm like, you can totally shut down one completely and start up another one. You can do it relatively quickly, but if your service takes time, then the role like.
No, I want to run. I have 4 machines. I want to run 4 machines. Then get transferred to the other one.
Oh, immediately switch over. There are ways of tweaking it that yes, you can do things like that. Yes. Because none of this is actually hosted on my laptop. It's all hosted on a cloud, and I'll explain that. I'll explain that in a second. But yes, I'm not running it all on my laptop because I'm not a sadist, or a masochist, I guess. Yeah, no, that's the way it would go. All right, so we also talked about rolling updates, and I showed you that we have a persistent volume there that the MySQL server is looking at. There's more stuff I'm going to not necessarily go right into because there's stuff like secrets and logging and monitoring events and UI. There's a lot more to it, but I want to get into some questions we commonly get right off the bat. So some comparisons. People ask, how does it relate to all these different Docker tools, for example? Docker Compose is multiple containers on the same host. Docker Swarm is clusters of container hosts, so basically allowing multiple Docker machines to sort of communicate and talk to one another. Docker Machine allows you to launch container hosts in several clouds, including on your own device. That's what you use for development now. It also allows you to manage remote container hosts. So if you look at Kubernetes, there's some overlap between what these guys do. And we also add routable networks and replication controllers to it. So if you look sort of kind of conceptually, Docker goes with the more Unix, like small tools that you can bind together to work together, whereas Kubernetes is sort of a more monolithic system. Also, Docker's logos are much cooler than ours. I feel like I really wish we had an octopus instead of like our random like geometric figure that doesn't make a lot of sense. I know, no, it's her. I've seen her blog and read her stuff. It's awesome. But yeah, they have much cooler stuff than us that way. The other question that often comes up is Mesos. Mesos is a multi-machine kernel. It turns a data center into sort of a logical system. Can do containers, and they've added a lot of features around containers, but that's not where it started. Consequently, it can do other types of distributed jobs like Hadoop a lot easier. Kubernetes, on the other hand, is management software for containers, has strong opinions about service discovery and logging. It can run on top of Mesos. And in fact, right now, if you want high availability for Kubernetes, running on top of Mesos is the way to get it. So those are the two I get a lot of questions about, the Docker components and Mesos. If you ask me questions later, when I stop for questions, I may or may not be able to go deeper into different technologies, because these are the ones I get asked about a lot. It's also important to note that we have really good relationships with both Docker and the Mesos team. They were all at, like, when we unveiled Kubernetes 1.0. And so we're all in communication, and it's actually, I'm shocked that it's a relatively happy and pleasant set of interactions between all these teams that are working on all the similar technology. It's not very competitive, it's more, it's much more cooperative than I thought it was going to be. So I want to talk about Container Engine. Now, I've mostly talked about developing on Kubernetes. I haven't talked about like administering Kubernetes. I mentioned briefly that I set up a cluster. That process goes something like this, right? You can set up a cluster. You choose an infrastructure. It can be Google, it can be Amazon, it can be Microsoft, it can be Rackspace, it can be a whole lot of others. I may have a skin in this game, right? I may have a preference, but obviously you can set up on all of those, and our docs will tell you how to set up on all of those. I won't say that one is better than the others. Then you choose an OS, right? Core OS, Atomic, or Red Hat Linux, or Debian, or CentOS, Ubuntu. You then provision machines. You boot some VMs up. You install the kube components. You're going to need N+1, a master and a node. And then you configure your networking, IP ranges for the pod, services, or service discovery network. And then you start clustering services, things like DNS, monitoring, logging. And then you have to manage kernel upgrades and OS updates and all of that. Or if you're a Google Cloud Platform customer, you go to Container Engine, and you'll get this screen, and there's a little button that says set up a container cluster, and you press it. And then you have you have a Kubernetes cluster. So Container Engine is a hosted version of Kubernetes. We set a few smart defaults, and we set up the DNS server for you, and the logging and the monitoring. We integrate it with all our stuff, but it is still Kubernetes. You still interact with it using kubectl, which is exactly what you do if it was installed on-prem. And in fact, that is what I am running on, because I don't like setting up all that stuff. I like pressing the button and have it do it for me. And what I like about this is that that's a lot of stuff, right? Like you're building you're building machines, and then putting, maybe you're taking physical machines and then putting VMs on them, and then putting Kubernetes on top of those, and then putting containers inside those. It's like a long way to go to just run a hello world, right? It's a big kind of undertaking. So what I like about Container Engine is that it really allows you to dip your feet in without necessarily like going whole hog. Container Registry is a hosted container registry that goes along with Container Engine. You can make it private, so if you don't want to share your images with the world, you don't have to. You can be used with Kubernetes Engine or not. And so now I'm getting at my wrap-up section. I'll stop for questions after this, but basically, Google has been developing and using containers to manage their applications for over 10 years. We had this discussion about Docker being horseshit, and got to a bigger thing about containers. Someone kind of asked me after, like, well, how does Google feel about this? We love containers. We think this technology is fantastic. But we are managing stuff at a scale that not a lot of people run into, right? Like, so looking at this, like everything at Google runs on containers: Gmail, web search, Maps, MapReduce jobs, GFS Colossus. even Google's Cloud Platform VMs. No, it's not true. VMs are VMs, right? But the containers tell them what to do. Everyone's like, this is a container, and this is a container, and even our VMs are containers. What? No, just kidding. No, but containers do all the management for them and run them. We launch 2 billion containers a week. So maybe we're a little vested in containers, and we think this technology is great. But I caution you. We think that containers are a way to manage scale, and we have scale that's at a very high level. You should carefully consider whether running everything on containers is right for you. Like I said, that's a lot of work, and maybe there are other solutions that make more sense. You really need to test this out and dip your feet into it before you go crazy. So when I say you should carefully consider whether running everything on containers is right for you, please, I beg you, do not hear you should run everything on containers, because that is not what I am saying. I'm saying you should carefully consider whether running everything on containers is right for you. Kubernetes is open source, so Kubernetes.io. It was started by Google, but we have turned it over to the foundation now, so it is technically not us running it anymore, although the foundation is all run by people and us, but like having that separation is good. And they have people on IRC all the time. That's Kubernetes Twitter handle. Roadmap right now, Kubernetes is at 1.0. We are looking to release 1.1 in late October. That is the target. I don't think we're going to hit that target. As I saw, the release candidate had slipped a little bit, but I mean, it's going to come out. It's going to come out within a month, probably. Of what's that? That's true. That's true. Yes, lawyers had gotten to me. So what's that going to entail? Support for Docker 1.8, graceful pod termination. Instead of shooting them in the head, you can kind of gently put them to sleep. Improvements to kubectl, support for up to 250 node clusters. Right now, recommended is 100. You can go more than that, but here there be dragons. Hopefully we'll get it to 250 node clusters by then. Also horizontal pod scaling. So right now, like you have to, something has to tell the pods to scale, to do that command. In 1.1, we'll just, if you're having too much load, we'll add more pods until, I don't know, until the server runs out of memory or something, I don't know. That'll tell me details of that. And then job objects. So if you like Kubernetes but are wondering what the hell I'm getting into, it's why I really point out that Container Engine can make dipping your toes in a little bit easier. Also, if you haven't tried Google Cloud Platform and you want to dip your toes in, we give you $200 of free credit for is it 300 for 2 months or 200 for 3 months? It's 300 for 2 months. It's 300 for 2 months. It's $300 for 2 months, and you will not, no matter what you do, you will not spend $300 on Kubernetes clusters in 2 months. You won't. So you can really play with it and dip your feet in and see what it is. So I want to say thank you. If you want to, and I'll pause for questions. If you want to get in touch with me, TP Ryan at Twitter, on Twitter is probably the best way. Either heckle me or ask me questions. Either way works. The Prezzo is not up. This is a lie. It will be after I'm done. I was changing it last night and changing it this morning. So bit.ly TP Ryan-chaos. It'll be up probably in the next 10 minutes. But with that, I'm going to break for questions. Anybody got questions? Yes. Okay. So you want to route all your communication through services. You can talk directly pod to pod, but it makes more sense to do services. And basically the way services work is I say, all right, these machines are MySQL, right? And in that case, I had a one pod service, so it wasn't that necessary. But I could, if I had multiple SQL servers set up, all connected to the same service, and then that's how the front ends would talk to it through the service and not directly to it. Yeah, there was a YAML file. I was trying to balance like showing config files and boring people to death versus, but yeah. So everything that ran when I hit a pause, it was processing a YAML file and doing something based on it.
So
Yes.
Generally, it's the DNS record to the server, and then you call the test environment variable.
Correct. Yeah.
But you said that it runs only on the master, so I'm limited to both the traffic limit for that master
Correct.
and all
Yep.
the other limitations.
Yep.
related.
So yes, high availability is coming. It's I think it's roadmap for version 1.5.
So it's like 2018.
No, not that far. It's supposed to be out next year. And right now you can get high availability with Mesos. I'm not entirely sure. I've just seen the bullet point somewhere that you can do that. I'm like, okay.
If I do that and put it on Mesos, I still have the limit of
Right.
having a container that has
Yep.
to jump from place to place. and
Yep. No, we need to get multiple masters working, and we're working on it. Okay. I've been really heavy in this section, so I'm going to go over. I'll come back. Yeah.
Is Kubernetes built from the same source code Google has been using for the last few years, or maybe?
That's a great question. So some people know about Borg, which is our internal container scheduling service. It is not the same source code. Those guys that worked on that basically got together and said, what if we could do it without making all the mistakes we made for the last 10 years? And so they built it from scratch, but it's all based in like what we learned internally about it. More importantly, it's based on a lot of the mistakes we made internally. Like we've like, don't go down that path. That's why pods were there from the beginning. Like we've sort of figured out some of this stuff. And so it's definitely the same engineers. And it may or may not at some point go internal too, but right now they are separate for that express purpose that we figured out what we should not do and got to fix those. Yes? API compatibilities. Right now it's Docker 1.7 and Kubernetes 1.1 will be compatible with Kubernetes. Whoa. Sorry. Kubernetes. Actually, I know somebody who is trying to run Docker on Docker, and whenever he talks about this, I just play the Inception theme. Like I don't even let him talk. So 1.8 is spec'd for 1.1. 1.8 of Docker for Kubernetes 1.1. Yes.
What would be the major value of adding Kubernetes into an environment that actually is already performing all this with based on salt stack, for instance?
I'd argue probably not a lot, right? Like, it's a tool, right? Like, it might work for you if you're already basically achieving this sort of environment without having to switch. Why switch? Okay. Yeah. Any other questions? All right, I'll give it 1, 2. All right, thank you guys very much. Enjoy the rest of the day. Thank you.